Hey, welcome to The Explainer. Today, we're going to pull back the curtain on machine learning. We'll cover everything from the huge, big picture ideas all the way down to the real-world challenges people face every day.
Have you ever wondered, how does YouTube know exactly what video you want to watch next? It feels like magic, right? Well, it's not magic. The answer is a super powerful field of computer science called machine learning.
So what is it? At its heart, machine learning is all about finding patterns in data. Think about it. Instead of us, humans, writing a million rules like if an email has the word discount, it's probably spam, we just don't. We let the machine look at tons of examples and figure out those rules all by itself. And this really nails the key difference. With traditional programming, we write the logic. We tell the computer, here's the input, here are the rules, now give me the output. But with machine learning, we flip that on its head. We say, here's a ton of input, and here's the output we want for each one. The machine's job is to figure out the rules, the logic that connect the two.
Okay, so where does machine learning fit into the grand scheme of things? I'm sure you've heard all these buzzwords flying around: AI, ML, deep learning. They're often used interchangeably, but they're not the same thing. Let's clear that up.
It all kicks off with artificial intelligence, or AI. This is the big one, the original dream. It's this huge, broad concept that's been around for decades. The whole idea of creating machines that can think and reason just like humans.
Now, machine learning, or ML, is a part of that bigger AI dream. You can think of it as the most successful, most practical way we found to actually do AI. It's the engine running under the hood of almost every smart thing you use today.
And then, if we zoom in even further, inside of machine learning, you've got deep learning, or DL. This is a really specialized subset of ML that uses these complex structures called neural networks, and they're actually inspired by the human brain. This is the stuff that's amazing at really complex tasks, like understanding images or your voice, especially when you have just mountains of data to work with.
Okay, so we've got the what, but what about the how? How does a machine actually learn? Let's get into the nitty-gritty, the building blocks that take a pile of data and turn it into something intelligent.
Well, there are really two main ways to think about learning. The first one is kind of like cramming for a test, The model just memorizes the training data. The second, and much more powerful way, is about actually understanding the underlying patterns so it can handle new stuff it's never seen before. And yeah, pretty much all modern machine learning aims for that second approach, to generalize, not just memorize.
And this learning can happen in a few different flavors, and it really depends on how much help we give the machine. The most common type is called supervised learning. This is where we give it labeled data, basically the answer key. We show it a picture of a cat and say, this is a cat. Simple enough. Then you've got unsupervised learning, where there are no labels. We just give it a bunch of data and say, go find something interesting. It's great for things like finding natural customer groups. And there are others too, like semi-supervised and reinforcement learning, which we're about to dive into.
And that brings us to reinforcement learning. This one is really cool. It's exactly like training a dog. You have a little software agent in an environment, and it learns by trial and error. When it does something good, you give it a reward. When it messes up, it gets a penalty. And over time, it just figures out the best way to do things to get the most rewards.
All right, so now we have a decent idea of how these machines learn. But where is this stuff actually showing up? The answer is pretty much everywhere. You're interacting with machine learning way more than you probably think. I mean, think about it. When a retailer knows exactly how much stock to have for a big sale, that's ML. When Uber or Ola surge pricing kicks in because everyone's trying to get a ride at once, yup, ML again. It helps banks decide if you're a good candidate for a loan. It even helps factories predict when a machine is about to break down so they can fix it before it causes a huge problem. It's this invisible brain optimizing things all around us.
Okay, but building a model that works on your laptop is one thing. Getting it out into the real world, where it has to operate 24/7 and stay up to date, that's a whole other challenge. This is where we start talking about putting models into production. So a really big question is, how do you keep these models from getting stale? Well, one way is called batch learning. You basically train the model, let it run for a while, and then every so often, say once a day or once a week, you retrain it from scratch with all the new data. But what if things are changing super fast, like with stock prices or trying to catch credit card fraud? For that, you need online learning, where the model is constantly learning, updating itself in real time as new information comes in.
And this batch learning approach, it's a constant cycle. You can see it here. You train the model, you launch it into the world, it does its job, and all the while it's collecting new data. But then, to keep it relevant, you have to hit the pause button, take all that new data, mix it with the old, and retrain the whole thing all over again. It's a loop that never really ends.
But here's the thing. Machine learning isn't just about algorithms and data. It's about people. Technology is only half the battle. So for this last part, let's talk about the human element and some of the really common challenges, the pitfalls that can trip people up.
And let me tell you, building a good ML model is hard. For starters, you might just not have enough data. Or maybe the data you have is a total mess. It's full of errors, weird outliers, just noise. And then there's this classic trap called overfitting. That's where your model gets so complicated that it ends up just memorizing the data you showed it instead of learning the actual patterns. It'll look brilliant on your training data, but the second you show it something new, it completely falls apart.
This is why you need a whole team of people to make this work. It's not a one-person job. You've got data engineers who are the architects, building the data pipelines. You have data analysts who are like detectives, looking at past data to find clues. Then, the data scientists come in to build the actual predictive models. And finally, you have the ML engineers, whose job is to take that model and make sure it can actually work in the real world, at scale, without breaking.
So when you boil it all down, machine learning isn't magic. Not at all. It's a seriously powerful tool, sure, but it's driven by data, and, most importantly, by a very deliberate, human-led process. So the only question left is, what problem are you going to solve with it? Thanks for tuning into this explainer.